The Vought F4U Corsair is an American fighter aircraft that saw service primarily in World War II and the Korean War. Demand for the aircraft soon overwhelmed Vought's manufacturing capability, resulting in production by Goodyear and Brewster. Goodyear-built Corsairs were designated FG and Brewster-built aircraft F3A for the first prototype delivery to the U.S.Navy in 1940, to final delivery in 1953 to the French. 12,571 F4U Corsairs were manufactured, in 16 separate models, in the longest production run of any piston-engined fighter in U.S. history. The Corsair was designed as a carrier-based aircraft, but its difficult carrier landing performance rendered it unsuitable for Navy use until the carrier landing issues were overcome by the British Fleet Air Arm. The Corsair thus came to and retained prominence in its area of greatest deployment, land-based use by the U.S. Marines. The role of the dominant U.S. carrier-based fighter in the second part of the war was thus filled by the Grumman F6F Hellcat, powered by the same double Wasp engine first flown on the Corsair's first prototype in 1940. The Corsair served to a lesser degree in the U.S. Navy, as well as the U.S. and British use. The Corsair was also used by the Royal New Zealand Air Force, the French Navy, Aéronavale and other, smaller, air forces until the 1960s. Some Japanese pilots regarded it as the most formidable American fighter of World War II, and the U.S. Navy counted an 11-to-1 kill ratio with the F4U Corsair. After the carrier landing issues had been tackled, it quickly became the most capable carrier-based fighter bomber of World War II. The Corsair served almost exclusively as a fighter bomber throughout the Korean War and during the French colonial wars in Indochina and Algeria. Development. In February 1938, the U.S. Navy Bureau of Aeronautics published 2 requests for proposal for twin-engine and single-engined fighters. For the single-engined fighter, the Navy requested the maximum obtainable speed, and a stalling speed not higher than 70 miles per hour. A range of 1,000 miles was specified. The fighter had to carry 4 guns, or 3 with increased ammunition. Provision had to be made for anti-aircraft bombs to be carried in the wing. These small bombs would, according to thinking in the 1930s, be dropped on enemy aircraft formations. In June 1938, the U.S. Navy signed a contract with Vought for a prototype bearing the factory designation V166B, the XF4U1, Bunno 1443. The Corsair design team was headed up by Rex Speisel. After mock-up inspection in February 1939, construction of the XF4U1, powered by an XR2800-4 prototype of the Pratt & Amp Whitney double Wasp twin-row 18-cylinder radial engine, rated at 1,805 horsepower, went ahead quickly, as the very first airframe ever designed from the start to have a double Wasp engine fitted for flight. When the prototype was completed, it had the biggest and most powerful engine, largest propeller and probably the largest wing on any naval fighter to date. The first flight of the XF4U1 was made on the 29th of May 1940, with Lyman A. Bullard, Jr. at the controls. The maiden flight proceeded normally until a hurried landing was made when the elevator trim tabs failed because of flutter. On the 1st of October 1940, the XF4U1 became the first single-engine U.S. fighter to fly faster than 400 miles per hour by setting an average ground speed of 405 miles per hour during a northeastwards flight from Stratford to Hartford. The USAAC's twin-engine Lockheed P-38 Lightning had flown over 400 miles per hour in January to February 1939. The XF4U1 also had an excellent rate of climb, but testing revealed that some requirements would have to be rewritten. In full power dive tests, speeds of up to 550 miles per hour were achieved, but not without damage to the control surfaces and access panels and, in one case, an engine failure. The spin recovery standards also had to be relaxed as recovery from the required two-turn spin proved impossible without resorting to an anti-spin chute. The problems clearly meant delays in getting the design into production. Reports coming back from the war in Europe indicated that an armament of two 30-in synchronized engine cowling manned machine guns, and two 50-in machine guns was insufficient. The U.S. Navy's November 1940 production proposal specified heavier armament. The increased armament consisted of three 50-caliber machine guns mounted in each wing panel. This improvement greatly increased the ability of the Corsair to effectively shoot down enemy aircraft. Formal U.S. Navy acceptance trials for the F4U began in February 1941. The Navy entered into a letter of intent on 3 March 1941, received Vought's production proposal on 2 April and awarded Vought a contract for 584 F4U fighters, which were given the name Corsair, inherited from the firm's late 1920s Vought F4U naval biplane Scout, which first bore the name on 30 June of the same year. The first production F4U performed its initial flight a year later, on 24 June 1942. It was a remarkable achievement for Vought, compared to land-based counterparts. Carrier aircraft are overbuilt and heavier, to withstand the extreme stress of deck landings. Design engine considerations. The F4U incorporated the largest engine available at the time, the 2,000 horsepower 18-cylinder Pratt & Amp Whitney R2800 double wasp radial. To extract as much power as possible, a relatively large Hamilton standard hydromatic 3-blade propeller of 13 feet 4 inches was used. Landing gear and wings. To accommodate a folding wing, the designers considered retracting the main landing gear rearward, but for the chord of wing that was chosen, it was difficult to make the landing gear struts long enough to provide ground clearance for the large propeller. The solution was an inverted gull wing, which considerably shortened the required length of the main gear legs. The anhedral of the wing's center section also permitted the wing and fuselage to meet at the optimum angle for minimizing drag, without using wing root fairings. The bent wing, however, was heavier and more difficult to construct. Offsetting these benefits, the Corsair's aerodynamics were an advance over those of contemporary naval fighters. The F4U was the first U.S. Navy aircraft to feature landing gear that retracted into a fully enclosed wheel well. The landing gear oleo struts, each with their own strut door enclosing them when retracted, rotated through 90 degrees during retraction, with the wheel atop the lower end of the strut when retracted. A pair of rectangular doors enclosed each wheel well, leaving a streamlined wing. This swiveling, after retracting landing gear design was common to the Curtiss P-40, as adopted for the F4U Corsair's main gear in its erstwhile Pacific War counterpart, the Grumman F6F Hellcat. The oil coolers were mounted in the heavily anhedraled center section of the wings, alongside the supercharger air intakes, and used openings in the leading edges of the wings, rather than protruding scoops. The large fuselage panels were made of aluminum and were attached to the frames with the newly developed technique of spot welding, thus mostly eliminating the use of rivets. While employing this new technology, the Corsair was also the last American-produced fighter aircraft to feature fabric as the skinning for the top and bottom of each outer wing, after the main spar and armament bays, and for the ailerons, elevators and rudder. The elevators were also constructed from plywood. The Corsair, even with its streamlining and high-speed abilities, could fly slowly enough for carrier landings with full flap deployment of 60 degrees. Technical issues, in part because of its advances in technology and a top speed greater than existing Navy aircraft. Numerous technical problems had to be solved before the Corsair would enter service. Carrier suitability was a major development issue, prompting changes to the main landing gear, tail wheel and tail hook. Early F4U-1s had difficulty recovering from developed spins, since the inverted gull wings shape interfered with elevator authority. It was also found that the Corsair's starboard wing could stall and drop rapidly and without warning during slow carrier landings. In addition, if the throttle were suddenly advanced, the port wing could stall and drop so quickly that the fighter could flip over with a rapid increase in power. These potentially lethal characteristics were later solved through the addition of a small, 6-in-long stall strip to the leading edge of the outer starboard wing, just inboard of the gun ports. This allowed the starboard wing to stall at the same time as the port. Other problems were encountered during early carrier trials. The combination of an aft cockpit and the Corsair's long nose made landings hazardous for newly trained pilots. During landing approaches, it was found that oil from the hydraulic cowl flaps could spatter onto the windscreen, badly reducing visibility, and the undercarriage oleo struts had bad rebound characteristics on landing, allowing the aircraft to bounce out of control down the carrier deck. The first problem was solved by locking the top cowl flap down permanently, then replacing it with a fixed panel. The undercarriage bounce took more time to solve, but eventually a bleed valve incorporated in the legs allowed the hydraulic pressure to be released gradually as the aircraft landed. The Corsair was not considered fit for carrier use until the wing stall problems and the deck bounce could be solved. Meanwhile, the more docile and simpler to build F6F Hellcat had begun entering service in its intended carrier-based use. Compared to the Hellcat, the Navy regarded the Corsair as fundamentally flawed for the requirements. While slower than the Corsair, the Hellcat was much preferred by the Navy, since the Hellcat was much simpler to land on a carrier. The Hellcat's great success combined with the Corsair's carrier landing issues meant the Navy released the Corsair to the U.S. Marine Corps. With no requirement for carrier landings, the Marine Corps deployed the Corsair to widespread and devastating effect from land bases. Corsair deployment aboard U.S. carriers was delayed until late 1944, by which time the carrier landing problems had been tackled by the British. Design modifications. Production F4U-1s featured several major modifications compared with the F4U-1. A change of armament to 6 wing-mounted, 15 M2 Browning machine guns and their ammunition meant that the location of the wing fuel tanks had to be changed. In order to keep the fuel tank close to the center of gravity, the only available position was in the forward fuselage, ahead of the cockpit. Accordingly, as a 237 gallons self-sealing fuel tank replaced the fuselage-mounted armament, the cockpit had to be moved back by 32 in and the fuselage lengthened. In addition, 150 pounds of armor plate was installed, along with a 1.5-in bulletproof windscreen which was set internally behind the curved plexiglass windscreen. The canopy could be jettisoned in an emergency, and half-elliptical plan-form transparent panels, much like those of certain models of the Curtiss P-40, were inset into the sides of the fuselage as turtle deck structure behind the pilot's headrest, providing the pilot with a limited rear view over his shoulders. A rectangular plexiglass panel was inset into the lower center section to allow the pilot to see directly beneath the aircraft and assist with deck landings. The engine used was the more powerful R2800-8 double Wasp, which produced 2,000 horsepower. On the wings, the flaps were changed to a NACA slotted type and the ailerons were increased in span to increase the roll rate, with a consequent reduction in flap span. IFF transponder equipment was fitted in the rear fuselage. These changes increased the Corsair's weight by several hundred pounds. The performance of the Corsair was superior to most of its contemporaries. The F4U was considerably faster than the Grumman F6F Hellcat and only 13 mph slower than the Republic P-47 Thunderbolt. All three were powered by the R2800. But while the P-47 achieved its highest speed at 30,020 feet with the help of an intercooled turbocharger, the F4U reached its maximum speed at 19,900 feet, and used a mechanically supercharged engine.